I saw it. Yeah, right now I start recording. Okay, I start recording right now. Yeah. And um, so basically, given this new concept, each work can be expressed by two ways. One is number of the whole. The other way is the like mole minute. For example, here, if we for example, take this line, for example, is like multiply 5, multiply 3. So basically, if we cancel the so this is the rate, and this is the mole, and so basically it is 5 mole take 3 minutes. So the total mole minute invested in 4 hole is actually 15. So basically, each hole, so basically this is for 4 holes. And if we divide it by 4, so basically each hole will take 15 over 4 like mole minute to dig. So basically this is some information we can use in the later problems. So this is a problem that we're going to use this concept. For example, like 5 holes. And if we use this, we actually will introduce a new concept that it has a small tank and a bigger tank, and then we will be able to use the let's read this problem that 5 holes can fill 10 small tanks in 80 minutes, and or 6 larger tanks in 90 minutes. What is the least amount of time it will take for 10 holes to fill small tanks and 8 large tanks? So basically, this is a multi-threaded problem, and we're going to use a 5-column table to address this type of the problem. So first, we're going to 5 holes can fill. So basically, this is the case 1. This is 5 holes case. 5 holes case for 10 small tank. For 10 small one, and so the work defined is actually, so the work here defined is 10 small tank. And so this is the multi-threading is at 5 holes. And in time is defined as 80 minutes. And this is the rate. This is the rate is actually for the small tank. So basically, then we have like 6 large tank. So 5 holes still can, so this is 5 for large. And it can fill 6 large tank in 90 minutes. So still 5 holes. And we're going to be able to calculate the rate to fill the small tank and the rate to fill the large tank. And so basically, the rate you actually just do division, and so basically this is rate small. So rate small, multiply 5 multiply 80 equals actually 10. So rate small equals 10 divided by 80 multiply 5. And we cancel this out, equals 40. 1/40th. So basically, given this rate, so what's the usage of the rate? The usage of the rate is that, each small tank can be filled by a single hose in 40 minutes. So basically, the reciprocal of the rate, the reciprocal of the rate is actually the amount of the work defined for the small tank. So a small tank is like, 40 hose minute. So one small tank is equal to the work. The work of a small tank is equal to 40 hose minute. Then basically when we do this problem, and we will be able to like this is rate large multiply 5 multiply 90 equal to 6. So the rate large equal to 6 divided by 5 and 90. And usually when you do this problem, try to factor it right away. So you're able to actually, then basically you're able to do like, I know that, 90 equal to 6 multiply 15. So basically you can cancel this out, and the rate large equal to 1/75. So basically this is 1/75. So the significance of this rate, so it's reciprocal, it's the work required to fill the large tank. So one large tank by working volume, it's actually equal to 75 hose minute. So basically, then we given equipped with those rate, we actually is able to solve the final question, how the least amount of time will take for 10 hose to fill 8 small tank, a large tank. So the 8 small tank is like 8 multiply 40. That's the hose minute plus 8 multiply 75. That's the working volume in the hose minute in terms of the, so basically this is how much you going to fill 8 small plus 8 large. So in the work volume, so right now, because they are mixed volume, I cannot say that 8 small plus 8 large, because it cannot, you cannot work with this. So basically I will, instead of using the tank number, I can use the addition of those number. Actually, it's going to be 920 is the hose minute. And right now, basically, I can change the rate, because right now I'm filling them together with 8 holes. And so basically 8 holes, and the rate is no longer a fraction of the tank. It's not no longer, it's the rate right now is just 1. So basically, it's just because one hose in terms of the hose minute, it's just 1. And so 8 holes filled together, my rate is actually, 8, because 8 holes will fill the tank at 8 hose minutes per second. So basically, it's just 980, 900, like, actually these are 10 holes. I read it the wrong way. So basically this is 10 holes. So basically the multi-thread is 10 and rate is 1. So 1 multiplied 10 equals 10. So basically it is that 920 divided by 10, I'm going to get 92. So that's the way that you are dealing with the multi-thread problem. So far is we kind of cover a bunch of problems for the, different. So we kind of just show you what we are doing. So um, so we are doing that because those two topics are closely related. We are kind of doing the mixture of lesson 1, lesson 2. So basically, we cannot totally separate it apart. So here, um, let's do the linear equations. Linear equation, I hope that everyone has been really understanding the linear equation well, and is so these are the basics we really have to understand, that linear equation in generic form, you have two type of actually has 3 forms. So this is the first form. First form is that like slope intercept form. Slope intercept form is popular because you are able to draw the picture really easily. Given a slope intercept form, for example, let me draw this picture, is 1/2 x plus 4. So 4 is the starting point which you can draw. So you count 1, 2, 3, 4. This is where the y-intercept is. Then 1/2 is just slope. Slope means that rise over run. But to draw the picture, you actually have to run first, then rise. So basically, to draw the picture, so slope intercept form, so find y-intercept first. Then run and rise on slope number. So the slope number is 1/2. So basically I run is always at the denominator. So run 2 and rise 1. So this is where you are able to find the next. And you can keep doing the same. You run 2, rise 1, run 2, rise 1. And here, going backward, you have to actually backward 2, then descend 2. So basically, because you are backwarding, so basically everything has to be reversed. So that's where you are able to draw the line. And then the definition of the slope, this is the rise run are both 1. This is, so the rise over run, so if you have 2 point, it's y2 minus y1 over x2 minus x1. So basically, it's fairly easy to find. Then another one is the slope intercept form. Slope, yeah, this is already slope intercept form. Then we actually, yeah, then you can actually do those problems fairly easily. Then there's another point slope form. So point slope form is a little bit different from the slope intercept form. And so it's just giving you a point and giving you a slope. You have to deal with it. And so this type of the problem, if you have difficulty remembering this, remember this formula, point slope form, you actually just remember the definition of the slope. That will help you out. So the definition of the slope is here. Definition of the slope is rise over the run. So basically, those are two known number fixed. So you actually, by remembering this, you also remembering the slope intercept form, because how you just, here, m equals y2 minus y1 over x2 minus x1. And if I replace x2 and y2 with just, if I say that y minus y1 equals x minus x1, so get rid of the subscript, get rid of the subscript for y2 and x2, you will get this. this actually, if you multiply it, multiply x minus x1 on both sides, you actually get the point slope form right away. So basically, all you really need to remember is just the slope definition. You will be able to remember the point slope form very easily. So this is, I think there's another final form is actually the standard form. So there's another, so there are three forms of the linear equation, and the sloping the stepped form and the point slope form. Then another one is ax plus by equals c. So this is the standard form. So you have three forms of, and it's fairly easily you can transform between them. Then for the linear equation, and a lot of times they actually will ask you to find a lot of times they actually will let you to find a parallel line or a perpendicular line, or doing a lot of things. So it's actually quite easy. So let's try to do just a few of those linear equation problems. And so you kind of just at least know. So Charles, are you comfortable with the linear equation different forms?
Yeah.
Okay, that's good. And Tracy, have you reached this topic in your classroom?
Yeah, we're kind of like starting it, but
You're
I know
starting
like
it.
the
Okay.
easier ones.
Okay, yeah. Okay. Looks good. Yeah, if you, so let me just pick one of the relatively difficult one, just to one example. We don't have time to go through all, but um, for example, let's say that if the graph, I kind of just randomly pick this one, and if the graph of those two are perpendicular, what's the value of the b? So first, to do this type of problem, we have to find the slope. To find the slope, we need to change this form. This is a standard form. A standard form we need to change into the slope intercept form. To do that, we need to isolate y. All we need to do is isolate y. So basically, it's just, we will put 2x. We can put 5y to the other side. We can put 7 to this side. Minus 7 equals 5y. And then this will show you that y is actually equal to, we need to multiply 1/5 on both sides. So 2 over 5x minus 7 over 5. So for this line, for line 1, the slope is 2/5. And then for this problem, we need to do the same thing, and trying to find out. So by isolate y, so basically it's by equal to negative 10x. I move to the other side, plus 7. And y equals going to be negative 10 over b x plus 7 over b. So this number is the slope. And and for they to be perpendicular, so perpendicular lines, their slope is negative reciprocal. Basically, they multiply, their product is -1. So 2/5 multiply negative 10 over b going to be equal to -1. and we can cancel the negative one on both sides. So basically it's actually, it's, you know, it's just 20 is equal to 5b, and b equals 4. So we can do it. So a lot of time you will just have to interpret whatever in the problem as the definition of the slope, and change the format between those, and try to do the problem. Okay, so let's do the system of equation. System of equation, I think, must be a fairly standard and a fairly, easy problem. And it's just typically you have two methods of doing it. And so one method is doing the substitution. The other method is the elimination. So there are two methods. And let's see the elimination. I think this topic is too easy. I'm going to, skip along, and the system of the equations. Substitution is especially easy in terms of, like, how do you choose the substitute, and when you choose substitute one of the equation is very easy. So basically this is already, already solved. If two of the equation, one of the equation is already solved or both solved, then it's very easy to use. And elimination, basically you have to, when you do the elimination, basically you are trying to gauge which one is easier to eliminate. For example, you can eliminate both x and y. For example, those two equations, I can eliminate either x or y, but obviously eliminating y is easier, because if I just plus them together, I can eliminate y. And to eliminate x, the effort we're going to know, we judge the coefficient. Basically, it's 2 and 3. In order to make elimination, I need to LCM 2 and 3 equal to 6. So basically, I have to synchronize both coefficient to 6. That involve multiplying both equations. That's not so fun, and doing addition is way easier. So basically, system elimination is just, do LCM on different coefficient first. Then, for example, this one I can do either eliminate x, eliminate y, eliminate x, LCM of 2 and 3 is actually equal to 6. So I have to synchronize both to 6. Eliminate y, basically LCM, like 3 and 4 is actually equal to 12. So basically, I have to synchronize both to 12. And either way is about the same effort. So it's really up to you to do whatever. And so in this example, they actually choose to eliminate x. Obviously, you can also eliminate y. Either way is fine. And yeah, so this is another problem that, it's able to choose to eliminate the C, but it can also choose to eliminate L. So that's about the same effort. And system of the equations, the common word problem. And common word problem actually have a lot of time actually have a lot of different point of view as the so basically, so Kelly and Jason are going out for a run, and Kelly leaves 2 minutes before Jason. And so if Kelly run for 7 miles, so you're still going to do a like a rate distance table. And also notice that, 7 miles an hour. So basically, and on one side is 7 miles per hour. The other side is at using leaves 2 minutes. So you actually have this is the rate, time, and the distance. And how long will take for Jason to catch up to Kelly. So basically, they are covering the same distance. It's just Kelly. So that you can build 2 cases. One is Kelly, one is Jason. And so Kelly runs 7 miles per hour and Jason runs 9 miles per hour. And so basically, how long it will take for Jason to catch Kelly. So let's say the time is t, then basically t is in minute. If it is in minute, it's actually you have to divide by 60 because the unit here is actually 9 miles per hour. Then here is t is plus 2 because Kelly started out 2 minutes earlier. Then basically they are both will be equal to the same distance. So basically their distance will be the same. Because their distance is the same, I wouldn't really put a D here. If I put D here, they are not much. Basically, you can just multiply in here. So 7 t plus 2 over 60. And down here is actually, 9 t over 60. So basically, those will be equalized because they are covering the same distance. So you will be able to form an equation here. So that's how you use this type of thing. So it's not necessarily an equation system because if you don't assume D, you actually, you just equation. It's not necessarily equation system. So sometimes it's not necessarily has to be equation system. But you will be prepared to use as much variable as you can. But all the time, if it come up, short as not an equation system, it still be fine. This is the up-down string, and it's also an easy problem. A lot of times they have age problem. This is also a fairly easy problem. Then I'm going to do the show the 3 equation and 3 variable. 3 equation, 3 variable actually is very much the same. It's very much the same. It's decide first you have to decide which variable to eliminate. You have to eliminate one of the variable to reduce this to a 2 variable system. And so you still judge the coefficient. So LCM 2, 1, and the 3 is equal to 6. So you have to synchronize everything to 6 in order to eliminate, the X to, so that's not very convenient. And so does this. But here, basically, LCM 111 is just 1. You don't have to do anything. You can just, add a subtract directly. So this is a good candidate to eliminate. So basically, when you're doing the elimination, always use LCM to judge the work volume and trying to do things first. Then one of the things I really like on the equation system is cheating the system. And the cheating the system is actually an extremely quick way. And it's a thought process that if you have some particular problem to solve, you don't even have to list the equation. You can even like do the mental math to solve the problem. That especially helpful in terms of, give you extra speed in doing the competition problem. Let's go for this one. And often there's no need to write a system equation if you have little common sense that will work. For this example, a cycling shop has bicycles and tricycles. If your shop currently has 42 cycles with total of 90 wheels in inventory, how much tricycle does the shop has? So basically, if you really do the equation way, you will say that, let's say that B is for bicycle, T is for tricycle. So B plus T is equal to 42, and like 2B plus 3T equals 90. So basically, we'll try to solve this equation, and by either this one, you can either do substitution or elimination, but this is not the quickest way. And let's assume a faster way. Let's use common sense. Let's assume that it's all bicycle. If 42 cycles are all bicycles, then basically I will got 84 wheels, because 42 multiplied 2 equals 82 or 84, and then I find myself, I need to plus 6 equals 94. I find myself 6 short of 90. If I'm 6 short of 90, then how do I going to solve this problem? If I replace a single bicycle with a tricycle, then basically I can catch this up by 1. So if I 41 bicycle and 1 tricycle, I'm going to have 84 wheel. So this logic is that the logic behind it is that every replaced bicycle by tricycle will add an extra wheel. So I'm short of 6 short of 90. So I just replace 6 bicycle with tricycles and the work is done. So basically, if I do that idea, then 42 minus 6 equals 36. So if I got 36 bicycle and 6 tricycles, then the problem is solved. And I don't have to do hard work. Let's see, how much hard work I have to do by doing this. For example, if I'm doing the substitution, I will say that B equals 42 minus T, and then 242 minus T plus 3T equals 90. And then that's 84 minus 2T plus 3T equals 90, and T equals 90 minus 84 equals 6. We are going to get the same result. And also notice the calculation. The eventual calculation that 94 minus 84, 84 is just twice of the, the assumed wrong case. This is assumed wrong case still show up exactly here in our like assumption and replace method. So by assumption and replace, you save all the effort to even have to list the whole thing. You don't even have to do the equation system, just do it, and you get a result right away. So how about that? Let's see, this is another example. that you can replace both way. This is a 2-pointer, 3-pointer. So Bradley scored 34 points in basketball by making 12 baskets. If each basket was worth either 2 or 3 points, how many 3-pointers did Bradley make? And so the problem is that he only makes 3-pointers. I'm going to make another assumption. I just make 3. If Bradley just makes 3-pointers, then what will happen? If he just makes 3-pointers, he will score 36 by making 12 baskets, because 3 multiplied 12 equals 36. And 36 is 2 extra. 2 extra than 34. So basically, if I replace one 3-pointer by a 2-pointer, I will get 1 point less. So in order to reduce 2 points, I need to replace 2 3-pointer with 2-pointers. So I can know that it's 10 3-pointer and 2 2-pointers. So that's the way that you can do this type of problem very quick. And in those cases, the difference is only like the difference is just a 1. Difference is 1. But if difference is 2 or other differences still work. Let's say that this is the stamp. The stamp that Melinda need to mail a package. She used 2-cent stamps and 10 stamps to mail the package. If she used 15 stamp worth of 75 cents, how many 10-cent stamps did she use? So I can assume that she all used 2-cent stamp. And because she is using 15 stamps, so this is 0.2 multiply 15 equals 0.3. So it was 30 cents. So he has to worth 78 and minus 30. It's actually 48 cents short. If I replace one 10-cent stamp with 2-cent stamp, I will gain extra 8 cents. So basically, 48 divided by 8 equals 6. So basically, I need 6 10-cent stamp. And we're going to 92-cent stamp. So that's the way that we can solve this problem. And you can also double check 6 10-cent is 60 cents. Then plus 9 multiplied 2 equals 18. So actually everything add up. So basically, this type of the problem, actually, it's a valid or deeply rooted in the quintessential problem of, math and its diagram. Let me explain this trick by graphing it. So basically, we're going to reach, 78 cents, and let's say that this is the 2-cent slope, and let's assume that this is the 10-cent slope. So basically, I can go all the way to here to assume everything is 2 cents. Then I come up short. Then this is the short distance, which can be made up by like 10 cents. And So that's 48 cent distance. And we know that the difference of the slope between them is 8. So for every unit, it will catch 8 of those. So basically, I know I had to backward 6 units in order to do it. So basically, after you do it, basically, you're going to travel the line by 9 step of 2 cent, then going up the remaining 6 of 10 cent higher slope, go up there. Either way, you can go up and go down. It's still about the same. And so that's just the way that, looks like a cheating the system, but it's not cheating. It just interpret the problem in a different way that make common sense and much quicker. And so we also going to do the racial problems in a deeper meaning. And so a ratio is just, a relationship between two quantity. And those two quantity could be totally different things. It doesn't has to be the same unit, same type. For example, speed is a ratio between distance and time. Distance has no relationship with time. And ratio could be, relationship between recipe of totally different material. For example, if you're making a cake and you will add both sugar and salt, and salt you will be like adding by unit of teaspoon, so really small. And if you're adding the sugar, you will be adding by cup, number of the cups. So basically, it could be totally different unit. And percent is just a spatial ratio with 100 as a base. And proportion is just two ratio being equal. Typical one is in the recipes, and doing those type program mostly involving with cross product. Cross product basically will get you there. And like racial problem, you can have relationship more than 2. It's continuous ratio like 2, 3, and 4. And in this case, you will just have to add up more relationship. And if you have multiple ratios, they are actually tell you a whole lot of information. You have total and red only and red plus blue. So there are a lot of combinations that red minus blue, and there are a lot of derived ratio. If you are given 2 ratio. So basically, just also to pay more attention to different ratios. A lot of time you actually are given very confusing problems. So let's see this example. That the Rayter family use 3 different size scoops to serve mashed potatoes, blobs, globs, and globs. And 2 blobs are equal to 1 glob, and 5 globs equal to 3 globs of mashed potato. A bowl holds 12 globs of potato. How many blobs was there in the? So this type of problem is deliberately trying to confuse you. And the way to solve this type of problem actually is not even, I don't like the reasoning it provides. Actually, there's a much better method. So basically, ratio problem, you actually can invent your own unit, do a unit conversion. So basically, use unit conversion. to solve ratio problem. For example, um, in a recipe of making a cake, you need one teaspoon of salt for every 2 cups of sugar. Then basically, the sugar within this cake, 1 teaspoon of salt is equal to 2 cups of sugar. So basically you can say that 2 teaspoons of sugar is, you can one means that is a recipe standard form. And 1 teaspoon of sugar equals to actually 2 like cups of sugar. And you can also, and this is a conversion rate. This is because this exists in one cake and one recipe of cake, this uniformly. So basically, with 1 teaspoon, you have to match 2 cups of sugar. And then with 2 cups of sugar on the backward way, you have to match up 1 teaspoon of the salt. So basically, you can invent very weird unit that in the calculation of the ratio. The disadvantage of it is that when you do this type of calculation, you actually calculate with the unit on, and it's impossible for you to make a mistake. So let's try to do this problem. And I don't have to read very confusing thing. I just invent a unit conversion. And this actually is not even invention because this is actually equivalent. I'm not relating them together because in recipe problem, I'm relating salt to sugar, and sugar and salt are different. They are just has to be in the right proportion. And here, glob, blob, they have equations. They have equalized 1. Basically, for example, like 2 blobs is equal to 1 glob. So basically, you will first to solve this problem, you will say that 1 equals 2 blob and 1 glob and equal to 1 glob and 2 blob. You have to write this conversion unit in 2 direction conversion so you can pick which ratio you want to use. And then 5 globs equal to, so basically 1 is equal to 5 glob and 3 glob equal to 3 glob and 5 glob. So basically it's asking how many blobs are there in a bowl. So in a bowl hold 12 glob. So 12, I'm going to start from 12 glob and we'll convert starting from 12 glob and we'll get 2 blobs. So 12 glob, I need to multiply one of the ratio to get rid of it. I need to get rid of this is on numerator, glob. So basically I need to pick this one. So this one is the one I'm going to pick because glob on numerator, I need to use glob on denominator to cancel that out. And this is the only one I can use. So 5, write everything together with the unit. So globs and 3 glob. Then here I can cancel the globs. So only thing left is globs. It's a little bit closer to blobs, but I'm not there yet. I need to find one with the glob and bob. Obvious, and glob need to be on the bottom. I cannot use this one because it's convert back to glob. This is not what I want. I need to convert to blob, so I need to pick this one. So this is the next one I really want. And so this is the one glob and the two blob. So I cancel this. And after cancel unit, I'm going to cancel the number. So this is 12 divided by 3 equal to 4. So 4 here. 4 multiply 5 multiply 2 equals 40. So 40 blob. And this is exactly, we got it. We don't use, we don't need to use the, this is a continuous, this is, the problem is using the continuous ratio. So then basically, I'm going to also show using the continuous ratio. So the continuous ratio, how do we use the continuous ratio? So we actually have to find the common, multiple and the common denominator, something like that. So basically, for multiple ratio, we actually, the best way is to use a table. So we know here is that, like one blobs equal to one gob. So basically, blobs and the gob, and there also has a like a glob. So two blob equal to one glob. 2 and 1. So this is the relationship between them. And then I have 5 glob and 3 gob. And then I have 5 and 3. So basically, in order to make this work, actually begin to synchronize. So here is the common one. How do I synchronize this to here? Basically, is actually this is a ratio 2 to 1. So I'm going to multiply 5 and multiply 5 on both here and here. I will actually synchronize it to 5. So 5 is still here, 3 is still here, because this is 1 multiply 5, this is reached to 5, so they'll synchronize. And 2 multiply 5 equals 10. So basically, glob, gob to blob to gob to globe is 10, 3, and 5. So basically, we are able to reach this ratio similarly. So basically, this is the way, this is the standard way if you make a table trying to do it. But this type of problem, I still prefer unit conversion. If you use unit conversion, it's way easier. You don't even have to list this table. So, just provide you different paths of solving the ratio and multiple ratio problem. And I don't think we have the time to cover the quadratic today. We have to cover quadratic because it is one of the requirements for AMC. But we kind of just will switch content around because it's very hard to cover those problems without, because the class definition, if we go for the Vieta and the quadratic, and actually solving equation system is an easier topic than quadratic of Vieta and the factorization. And we're going to cover it the next time because we kind of just have to switch it around. Otherwise, I don't want to attack a more difficult problem first without covering an easier problem first. So I think we can finish the ratio problem. And so the ratio problem, so the ratio problem is just, if you're given a ratio, it not necessarily has to written in this format. You actually is able to swap the location, so swap AC, it still work. And you can also flip up and down, so A could be going, and you swap the side, the left and the right you can swap, and everything can be swapped as long as the diagonal still stay a same pair. So still if it's AD equals BC, so basically, if everything still multiply to this result, it still works. So just keep this in mind. And also solving those types of problems not necessarily have to do, and it's using cross multiplication, but for me, it's not always using cross multiplication. For example, 1/4, in order to go from 1/4 to 1, I just multiply 4. So if I multiply 4 from top to bottom, it's 56. And it's kind of just scaling, horizontal scaling. This is vertical scaling. If you have something that vertically you have an easy multiple to manage, you can do it. Or for example, if I say that I can find out, you can also do horizontal scaling, because I can find out, in order to get from 1/4 to 14, actually I multiply 56. This is the factor I'm going to multiply. So if you multiply 1 to 56, you're still going to get the same result. So this is especially when you're doing the competition problem, and the cross multiplication may not be necessarily the fastest one. And if you are able to find horizontal or vertical scaling, it's actually faster and easier to do. And also there's one thing is that given those two ratios are the same, there are more to it. So basically you can minus AB equals A plus C, and B plus D. And so their difference is also the same. So they are actually, given those are equal, actually A, it's actually equal to A plus KC, and A plus KD, and equal to, for example, LA plus KC and LA plus KD. So basically, when you have a ratio equal, this is a proportion equal, and there are a lot more information than itself. There are a whole lot of things. So basically, given a ratio, proportion, you are able to swap them around, flip them around, change the order, and then going to do the scaling up in a multiple way. So it just has much more things. Could be, I'm going to drag out a little bit, just finish up this portion, and then we will start from the next one. So the percentage problem are extremely tricky. Percentage problem usually you have to manage it as a percentage problem. You actually have to manage a lot of time. You manage as a multiplication problem. And for example, there's this one. Let's go for this one. And you're asking what percentage of the 5 dozen cookie remains. It's asking percentage, okay? When it asks a percentage problem, if you give a 60 cookie and all the way it's using the percentage, and you don't even have to consider 60. You can just do it without 60. She gave 40% of cookie away, so she got 60% left. So it's 0.6. And then 25%, so it's multiply, 0.75 she gave away. And she ate a third of left, so it's multiplying 8, so it's 2/3 left. And what percentage? So basically, and when I saw a fraction, I'm trying to convert everything to fraction. So this is just 3/5 multiply 3/4 multiply 2/3. Cancel this out to, so 3/10 equals 30%. Notice I'm doing this problem without even 60 cookie. So a lot of time is that, if you do the percentage problem, converting to the fraction or, decimal first. And this is going to be the last problem. And starting with 190, you spend 20%. Your friend pay you the amount equal to 20% of what you left. How much money are you right now? So basically, if you use scaling factor point of view to do this problem, basically, when I do this problem, I never view it this way, because when you start with, you spend 20, is actually multiply 0.8. And then when you do like your friend pay you amount whatever left, so basically it's actually multiply 1.2. So basically the whole problem is 195 multiply. So this is actually the way that you actually can do it. And this way, you will actually get the same result. So let's, so this is kind of volatile market. Volatile market, how much money. So when the stock drop a lot, it's volatile. When it's volatile, it's very easy to lose money. And this is just an example that, how much you can lose. It's just lose 50%, come 50% back, lose 50% again, then rise. It looks like, 50%, 50%, 50%, 50%. Looks like you are doing very well. In fact, is that this 50%, 0.5 multiply 1.5, and then multiply 0.5 multiply 1.5 again. So if you do this is just 1/2 multiply 2/3 multiply 1/2 multiply 2 or 2 or 3/2. So basically it's going to be 16 over 9 or 9 over 16, 9/16. 9/16 is actually through those 4 action of volatile move, you actually lose almost half the money. So it's actually quite detrimental to the portfolio. So That's what's okay. I think that's all for today, and going to send the other material and note. And anyway, we actually cover a lot of result, like we did cover a whole lot of the solving equation systems. So that will be good. Okay, I think have a nice one, everyone.
Thank you.
Thank you. 这个是1个半小时的。